Have you ever closed your eyes in a quiet room and wondered if the world around you is still there? I do not mean this in a metaphorical sense. I mean it quite literally. When you turn away from the chair in the corner, does it cease to be a solid object and dissolve into a haze of probability? When you are not touching the cool sheets of your bed, do they actually exist in any defined form? It feels like a question for a philosopher, or perhaps a child, the kind of thought we dismiss as we grow older and become certain of the world's permanence. We feel the solidity of the floor beneath our feet. We see the unwavering light of the stars. The universe feels dependable, concrete, and real. But for the last 100 years, the most brilliant minds in our species have been quietly uncovering a truth that shatters this sense of safety. They have found that the solid reality we think we inhabit is not solid at all. It is a phantom. It is a trick of perspective, and at the very bottom of everything, in the subatomic basement of the universe, reality behaves less like a machine and more like a hallucination that only stabilizes when we look at it. Tonight, I want to take you on a journey into the strange heart of quantum mechanics. We are going to explore the theories that keep physicists awake at night, not because they are complex, but because they imply something terrifying about our existence. We will walk through the valley of the quantum shadow, where particles can be in two places at once, where the past can be changed by the future, and where you might just be a lonely mind floating in an infinite void. But do not be afraid. We will walk this path together with a gentle step, finding the beauty hidden inside the terror. To understand the first and perhaps most unsettling crack in our reality, we must first look at your hand. Hold it up in front of you, or simply feel the weight of it resting by your side. It feels solid. It feels continuous. If you clap your hands together, you hear a sharp sound, a collision of matter against matter. It seems undeniable that you are a physical object occupying a physical space. But this is the first illusion. If we were to zoom in on the skin of your fingertip, magnifying it thousands of times, we would see cells. Zoom in further, and we see molecules of protein and water. Zoom in again past the distinct shapes of chemistry, and we reach the atoms. We are taught in school that atoms are like tiny solar systems, with a nucleus in the middle and electrons orbiting around it like little planets. But this model, while comforting, is deeply misleading. If the nucleus of an atom were the size of a marble sitting on the center line of a football stadium, the electrons would not be in the stands. They would be tiny specks of dust whizzing around in the parking lot outside. Everything in between, the stands, the field, the air, is empty space. An atom is 99.9999999% empty space. The only reason your hand does not pass through the table when you lean on it is not because the matter is solid, but because the electromagnetic fields of your atoms are repelling the electromagnetic fields of the table's atoms. You are hovering, forever suspended on a cushion of force, never truly touching anything. This realization that we are mostly ghosts made of emptiness is disorienting, but it is not yet terrifying. It is simply a matter of scale. The true terror begins when we ask, what are those tiny particles, those electrons and protons, actually doing in that vast empty space? To answer this, we must travel back in time to a chilly autumn week in 1927, to the city of Brussels. Imagine a gray stone building, the Hotel Metropole. Inside, sitting around a long table, are the greatest geniuses of the 20th century. Albert Einstein is there, his hair wild, his expression concerned. Sitting nearby is Niels Bohr, the Danish physicist with a heavy brow and a mind like a steel trap. Marie Curie, Erwin Schrodinger, Werner Heisenberg. They are all there. This was the 5th Solvay Conference, and it was perhaps the most intelligent gathering of human beings in history. They had gathered to discuss a new theory called quantum mechanics, a set of rules that seemed to describe how the subatomic world worked. But the debate that unfolded in that room was not just about math. It was about the nature of reality itself. Einstein was uncomfortable. He believed in a universe of strict cause and effect, a universe where objects had definite positions and speeds, regardless of whether anyone was looking at them. God does not play dice, he famously said. He wanted the universe to make sense. But Niels Bohr and his young protege, Werner Heisenberg, were arguing for something else. They were suggesting that down at the bottom of the rabbit hole, the universe stops being a collection of things and becomes a collection of probabilities. To understand why this terrified Einstein and why it should unsettle you, we have to look at the experiment that started it all, the double-slit experiment. This is the most famous experiment in the history of physics, and for good reason. It is the moment where the universe reveals its magic trick. The setup is deceptively simple. Imagine you have a light source, like a laser, and a screen with 2 narrow vertical slits cut into it. Behind that screen is a back wall where the light will land. If you shine the light through the 2 slits, what would you expect to see on the back wall? You might expect to see 2 vertical bands of light corresponding to the 2 slits. But that is not what happens. Instead, you see a series of many vertical bands, light, dark, stretching out across the wall. This is called an interference pattern. It happens because light acts like a wave, like ripples in a pond. When the light wave hits the 2 slits, it splits into 2 new waves. These 2 waves ripple out and crash into each other. Where 2 crests of the waves meet, they make a brighter light. Where a crest meets a trough, they cancel each other out, creating darkness. This was established way back in 1801 by a man named Thomas Young. It was beautiful, but it wasn't scary. Waves do what waves do. But in the 20th century, physicists decided to try this experiment with matter. They fired individual electrons, tiny particles of matter, at the double slits. Now, imagine you are firing tennis balls at a wall with 2 holes. You would expect the tennis balls to go through one hole or the other and pile up in 2 heaps on the other side. Electrons are particles, just like tiny tennis balls. So, the physicists expected to see 2 bands on the back wall. They fired the electrons one by one. Click, click, click. Slowly, the pattern built up on the recording screen. But when they looked at the result, they did not see 2 bands. They saw the same interference pattern as the light. Many bands. Strips of electrons, strips of nothing, strips of electrons. The physicists were baffled. How could individual particles create a wave pattern? It was as if each single electron, upon reaching the slits, decided to split in 2, go through both slits at the same time, interfere with itself like a ghost, and then recombine on the other side. But that is impossible. An electron is a single, indivisible point of matter. It cannot be in 2 places at once. Or so they thought. So the physicists decided to be clever. They said, let us watch the electrons. We will put a sensor, a detector, right next to the slits. We will spy on the electron to see which slit it actually goes through. They set up the equipment. They turned on the electron gun. They turned on the detector. And this is the moment where the universe broke. When the detector was turned on and watching, the electrons behaved perfectly normally. They went through the left slit or the right slit. On the back wall, they formed 2 simple bands. No interference pattern, no magic, just tennis balls hitting a wall. The physicists were stunned. They turned the detector off. The interference pattern returned. They turned the detector back on. The pattern disappeared. Let this sink in for a moment. The electron knew it was being watched. When no one was looking, the electron acted like a wave of possibility, existing in many places at once, rippling through both slits simultaneously. It was in a state of what we call superposition. But the moment an observer or a measuring device looked at it, the electron snapped to attention. It was forced to choose. It collapsed from a wave of infinite possibilities into a single, solid particle with a definite location. This phenomenon is called the collapse of the wave function, or simply the observer effect, and it implies something that goes against every instinct we have about the world. It suggests that the properties of reality, position, speed, existence itself, are not fixed. They are not there, waiting for us to find them. They are brought into existence by the act of measurement. Niels Bohr, at that conference in Brussels, looked at Einstein and said, in essence, the electron does not have a position until we measure it. He was not saying we do not know where it is. He was saying it is nowhere. Before you look, the electron is a ghost. It is a smear of probability spreading out across the universe. It is only when the eye of the observer lands upon it that the universe says, okay, here it is. This is the Copenhagen interpretation of quantum mechanics. It is the standard textbook explanation taught in universities around the world. And if you think about it deeply enough, it is terrifying. It means that the objective world, the world of things that exist independently of us, might be an illusion. It suggests that reality is not a pre-rendered movie that plays whether we are in the theater or not. Instead, reality is like a video game that only renders the part of the map you are currently looking at. When you turn your back on your room, does the room stay there? Quantum mechanics says, not exactly. The atoms in the room, unobserved, lose their definite positions. They spread out. They become fuzzy. They enter a state of superposition. The chair is not strictly in the corner anymore. It is a probability wave of a chair that is mostly in the corner, but also slightly everywhere else. It is only when you turn back around, when your photons interact with it, when your brain processes the data, that the wave function collapses and the chair snaps back into the corner, solid and still. Einstein hated this. He spent the rest of his life trying to disprove it. He wanted a universe that was real, independent of him. But experiment after experiment, for nearly 100 years, has proven Bohr right. The universe is participatory. We are not just an audience watching the cosmic play. We are the actors, the directors, and perhaps even the playwrights. There is a famous question. If a tree falls in a forest and no one is around to hear it, does it make a sound? The quantum physicist answers, if no one is around to measure it, the tree is in a superposition of falling and not falling, and the sound is a wave function that has not collapsed. The forest itself is a blur of possibilities until a witness arrives. This leads us to the edge of a profound abyss. If reality requires an observer to become defined, then what was the universe doing before life evolved? For billions of years, before eyes and brains existed to measure the stars, was the universe just a vast, uncollapsed wave function? A swirl of gray fog where nothing truly happened because nothing was there to see it? Or is there something else, some universal observer that keeps the lights on when we are asleep? The silence of the quantum realm offers no easy answers. It only offers the mystery. It tells us that The boundary between the out there and the in here is not as thick as we thought. We are woven into the fabric of the cosmos in a way that is intimate and inescapable. We are the collapses of the wave. We are the anchors of reality. As you lie there now, feeling the weight of your body, remember that you're a collection of trillions of atoms, each one a tiny cloud of probability. You are a standing wave of existence, and the world around you is waiting for your gaze to give it form. It is a heavy responsibility, perhaps, to be the creator of your own reality, but it is also a beautiful one. It means you are never truly alone. You are always in dialogue with the universe, and it is always responding to you. The air in your room is quiet. The shadows are still. But in the darkness, the probabilities are dancing. They are waiting for the morning. They are waiting for you to open your eyes and say, "Let there be light." And just like that, the wave will collapse, and the world will begin again. But if the mere act of observation can change reality, what happens when the possibilities are too vast to collapse into a single outcome? What happens when the universe refuses to choose? This brings us to a theory that is even more unsettling than the observer effect. A theory that suggests that every time a decision is made, the universe does not collapse. It splits. There is a feeling that haunts us all, usually late at night, when the house is quiet and the distractions of the day have faded into the dark. It is the heavy, sinking feeling of regret. It is the question that starts with two simple words. What if? What if I had taken that other job? What if I had not said those angry words to the person I loved? What if I had turned left instead of right? We look back at the timeline of our lives, and we see a series of locked doors, paths we did not take, versions of ourselves that never came to be. We mourn these lost possibilities. We treat them as fantasies, as dreams that evaporated the moment we made a choice. We tell ourselves that there is only one reality, the one we are living in right now, and that everything else is just imagination. But there is a theory in quantum physics that says this comforting belief is wrong. It suggests that those doors are not locked. It suggests that those paths did not evaporate. It implies that every single time you were faced with a choice, no matter how small, the universe did not choose one path. It chose both. This brings us to the second terrifying theory on our list, a concept that completely dismantles the idea of a single, unique you. It is called the many worlds interpretation. To understand it, we must leave the conference rooms of Europe and travel forward to 1957 to Princeton University. There, a young doctoral student named Hugh Everett III was looking at the math of quantum mechanics and finding a glaring contradiction. The establishment, led by Niels Bohr, said that the wave function collapses when observed. They said the universe is a fuzz of probability that magically snaps into a single reality when we look at it. But Everett asked a question that was as simple as it was devastating. Why? Why should the universe care if we are looking at it? Why should a mathematical wave, which describes the evolution of a particle perfectly, suddenly stop and break just because a human being walked into the room? Everett proposed a radical alternative. He looked at the equations and said, what if the wave function never collapses? What if the electron at the double slits does not choose the left slit or the right slit? What if it actually goes through the left slit in one universe and the right slit in another? Everett suggested that every time a quantum event has multiple possible outcomes, all of them happen. The universe literally splits apart, peeling off into separate, non-communicating branches. In one branch, the electron is on the left. In another, it is on the right. And This is the part that should make you pause. You split along with it. There is a version of you that sees the electron on the left, and there is a separate, equally real version of you that sees it on the right. Both of them think they are the only real you. Both of them have your memories up to that moment. But from that point on, their lives diverge forever. This is the many worlds interpretation, and while it solves the math problem of the collapse, it creates an existential nightmare. It means that reality is not a single timeline like a piece of string. It is a tree, an infinitely branching fractal of universes, growing larger and more complex with every passing fraction of a second. Consider the famous thought experiment known as Schrodinger's cat. Erwin Schrodinger, one of the founders of quantum mechanics, came up with it to show how absurd the current theories were. He imagined a cat sealed inside a steel box. Inside the box, there is a tiny amount of radioactive material, so small that in the course of an hour, there is a 50% chance one atom will decay, and a 50% chance it will not. If the atom decays, it triggers a Geiger counter, which releases a hammer, which shatters a vial of poison, which kills the cat. If the atom does not decay, the cat lives. According to the standard view, before you open the box, the atom is in a superposition of decayed and not decayed. Therefore, the cat is in a superposition of being alive and dead at the same time. It is a ghost cat hovering between existence and non-existence. When you open the box, you force the universe to decide. The cat snaps into being either alive or dead. But Hugh Everett looked at this box and saw something different. He said that when the atom enters a superposition, it drags the detector, the poison, the cat, and eventually the observer into the superposition with it. In Everett's view, the moment the atom has a chance to decay, the entire universe splits in two. In one universe, the atom decays, the poison is released, and the observer opens the box to find a dead cat. They feel sad. They bury the cat. Life goes on. In the other universe, inextricably separated from the first, the atom does not decay. The observer opens the box and finds the cat alive and purring. They feel relieved. They feed the cat. Both observers are real. Both outcomes happened. There is no ghost cat. There are simply two different cats in two different worlds. Now, you might think, well, that is just a story about atoms and cats. It does not affect me. But remember, you are made of atoms. Every neuron firing in your brain is a chemical process driven by the movement of electrons and protons. These particles are governed by quantum rules. This means that every thought you have, every hesitation, every coin toss, every random fluctuation in your body's chemistry is a branching point. Think back to a moment in your life where you made a mistake. Maybe it was a car accident. You looked down at your phone for 1 second, and that was enough. In the many worlds view, there is a universe where you did not look down. In that universe, you drove home safely, kissed your family, and lived a long, happy life, completely unaware of the tragedy that befell your other self. But the reverse is also true. Think of a time you narrowly avoided disaster. That time you stepped back onto the curb just as a bus rushed past. In this branch of reality, you felt the wind on your face and your heart racing. You went home and told the story of your near miss. But in another branch, just a hair's breadth away, you did not step back. The bus did not miss. Your story ended there. This concept leads to a profound sense of cosmic vertigo. It suggests that there are trillions upon trillions of versions of you filling up the multiverse. There are versions of you who are billionaires, versions of you who are beggars, versions of you who died in infancy. and versions of you who have achieved everything you ever dreamed of. They are all out there, separated by the thin, impenetrable walls of quantum probability. You can never meet them. You can never know them. But they are as real as the person breathing in your chest right now. This idea was so radical, so disturbing to the scientific community of the 1950s, that Hugh Everett was ridiculed. Niels Bohr and the old guard of physics dismissed him. They could not accept a universe that was so wasteful, so extravagant with its realities. Crushed by the rejection, Everett left theoretical physics. He went to work for the government, analyzing nuclear war strategies. A grim job for a man who believed in infinite worlds. He died young, of a heart attack, perhaps never knowing that decades later his theory would become one of the leading explanations for reality among cosmologists. There is a tragic irony in Everett's life. In our branch of the universe, he died feeling unappreciated. But if his theory is correct, there must be a branch where the great physicists of his day stood up and applauded him. A branch where he won the Nobel Prize. A branch where he lived to see his ideas transform the world. We just happen to be in the branch where that did not happen. The many worlds interpretation changes the way we look at our own history. We tend to view the past as a single, solid road that led us to this moment. We think of ourselves as the inevitable result of history. But in a branching universe, the past is not a road. It is a sprawling root system. We are just one tiny tip on a growing plant that covers the entire dimension of time. And the future is not a destination we are heading toward. It is an explosion of possibilities that will all be realized. This removes the weight of destiny, but replaces it with the weight of infinity. It means that everything that can happen does happen, somewhere. If the laws of physics allow it, it exists. There is a universe where the dinosaurs were not wiped out by an asteroid and evolved into intelligent civilization. There is a universe where the Library of Alexandria did not burn. There is a universe where Earth is the only lifeless planet in a teeming galaxy, and a universe where we are the only life in a dead cosmos. This vastness can make you feel incredibly small. If there are infinite versions of you, what makes you special? Are you just a disposable copy, a random roll of the quantum dice? It is a thought that can induce a deep, cold loneliness. You are trapped in this specific branch of reality, forced to live out the consequences of this specific sequence of events, while an infinite number of other yous are living out every other variation. But there is also a strange, gentle comfort in this theory. Think of the regrets we spoke of earlier, the lost loves, the missed opportunities, the mistakes that keep you awake. The many worlds interpretation tells you that those losses are not absolute. Somewhere, in a branch that split off long ago, you did take that job. You did save that relationship. You did make the right choice. Those versions of you are happy. They are living the lives you mourn. Your grief in this world is the shadow of their joy in another, and their grief in a different world might be the shadow of your joy in this one. It connects us to a totality of existence that is far bigger than our individual struggles. We are part of a grand, exhaustive exploration of every possible way to be a human being. The universe is experiencing your life in every variation, leaving no stone unturned, no tear unshed, no laugh unheard. You are not just one person. You are a choir of infinite voices singing every possible song of your life simultaneously across the void. Some physicists have taken this idea even further, to a place that is truly terrifying. They call it quantum immortality. The logic goes like this. If your consciousness is the observer, and you can only observe a universe in which you exist, then you can never experience your own death. If you are in a situation with a 50-50 chance of survival, like the cat in the box, the universe splits. In one branch, you die. The lights go out. There is no observer left. But in the other branch, you survive. Your consciousness continues. Since you cannot experience non-existence, you will always find yourself in the branch where you survived. Imagine playing Russian roulette with a quantum trigger. Click, you survive. The universe splits, and in the other world, you died. But you are not there to know it. You are here, holding the gun, surprised you are alive. Click, you survive again. Click, you survive again. To an outside observer, you seem incredibly lucky, practically miraculous. But to you, it is the only possible outcome. You are trapped in a subjective reality where you simply cannot cease to exist. As you age, as you face illness, you might find yourself surviving against all odds, over and over, trapped in a body that grows older and older in the increasingly thin slice of probability where you are still alive. It is a harrowing thought that we might be condemned to life, unable to leave the stage because there is always one tiny probability thread that keeps us going. Of course, this is just a hypothesis, a dark extrapolation of the math, but it highlights the strange, unbreakable bond between the observer and the universe. We are locked together in a dance that might be eternal. As you sit here now, breathing in the quiet air of your room, try to visualize the splitting. With every beat of your heart, with every shift of an electron in the lamp beside you, the world is peeling apart. You are riding the crest of a wave that is constantly breaking into new realities. You are gliding through the multiverse, navigating a ship of consciousness through an ocean of infinite yous. The silence around you is not empty. It is packed full of the worlds you cannot see. The air is thick with the ghosts of the things that almost happened. But here, in this branch, in this moment, you are safe. You are the anchor of this specific reality. And even if there are a trillion other versions of you, none of them are here, reading these words, feeling these feelings. This moment, right now, is yours alone. It is a unique coordinate in the infinite matrix of the multiverse, and that makes it precious. But if the multiverse separates us into isolated islands of reality, is there any way to bridge the gap? Is there any way for two things, once connected, to remain connected across vast distances, defying the laws of space and time? This question leads us to the next stop on our journey. We must leave the branching worlds of Everett and descend into a phenomenon so strange that Einstein himself mocked it as spooky action at a distance. We are going to explore the bind that ties the universe together, a connection so deep that it suggests space itself might be an illusion. We are going to talk about quantum entanglement and why it means that you might be intimately connected to particles at the other end of the cosmos, in a way that can never be broken. There is a quiet sadness that comes with looking at the stars. It is the sadness of distance. When you stand in your backyard on a clear, cold night and look up at the constellation of Orion or the faint shimmer of the Pleiades, you are feeling the immense, crushing gaps that separate everything in our universe. The light hitting your retina left those stars decades, centuries, or even millennia ago. You are seeing ghosts, and you know with a heavy certainty that you can never touch them. You are here on this small rock, and they are there across an ocean of vacuum so wide that the human mind cannot truly comprehend it. We are taught that space is a barrier. It is the great divider. It keeps things apart. If you want to affect something, if you want to push a chair, or speak to a friend, or send a signal to a rover on Mars, you have to cross that space. You have to send a wave, or a particle, or a hand, traveling through the gap. And because nothing can travel faster than the speed of light, there is always a delay. There is always a lag. We are all trapped in our own little bubbles of now, waiting for messages from the past. This idea that things are separate, that they only affect each other by touching or sending signals across space, is called locality. It is the bedrock of our intuition. It is the rule that keeps the universe sane. It ensures that what happens in a galaxy a billion light years away does not instantly ruin your breakfast. It gives us a sense of privacy, of autonomy. But the third theory on our list, perhaps the most famous and most misunderstood of them all, tells us that this rule is a lie. It tells us that space is not the barrier we think it is. It suggests that at the fundamental level, distance might be an illusion. We are about to enter the strange world of quantum entanglement, a phenomenon so bizarre that Albert Einstein refused to believe it could be true, mocking it with the now famous phrase, spooky action at a distance. To understand why this is terrifying, we have to go back to the intellectual battle between Einstein and the quantum pioneers. By 1935, Einstein was frustrated. He felt that quantum mechanics, with its probabilities and its fuzzy realities, was incomplete. He believed there had to be a real world underneath the math, a world where particles had definite properties, whether we looked at them or not. So, along with his colleagues Boris Podolsky and Nathan Rosen, he wrote a paper designed to expose the absurdity of quantum theory. This is known as the EPR paradox. Einstein's argument went something like this. Imagine we create two particles, let us say two electrons, in a way that links their fates together. In the quantum world, properties often come in pairs that balance each other out. For example, electrons have a property called spin. You can think of it loosely like a spinning top, although it is much more abstract than that. An electron can spin up, or it can spin down. If we create two electrons together in a specific way, the laws of physics demand that their total spin adds up to zero. If one is spinning up, the other must be spinning down. They are a matched pair. They are entangled. Now, imagine we take these two entangled electrons and we separate them. We put one in a box and keep it here on Earth. We put the other in a rocket ship and send it to the Andromeda Galaxy, 2.5 million light years away. According to quantum mechanics, until we measure them, neither electron has a definite spin. They are both in a superposition of spinning up and spinning down at the same time. They are both undefined. Here is the trap Einstein set. He asked, what happens if I open the box here on Earth and measure my electron? Let us say I look, and the wave function collapses, and I find it is spinning up. Instantly, because the conservation of energy and momentum must be preserved, the electron in Andromeda must become spin down. It does not matter that it is 2 million light years away. It does not matter that no signal has had time to travel between them. The moment I force my electron to choose a state, its partner across the cosmos makes the opposite choice instantaneously. Einstein said this was impossible. It violated the speed limit of the universe. Nothing can travel faster than light, not matter, not energy, not information. If the electron in Andromeda reacts instantly to what I do on Earth, it implies that they are communicating at infinite speed. It implies that space does not exist for them. Einstein argued that the only rational explanation was that the particles were never in a superposition at all. He believed they were like a pair of gloves. If I put a left glove in one box and a right glove in another, and send them to opposite ends of the universe, of course, finding the left glove here means the right glove is there. The gloves did not decide at the moment of measurement. They were always left and right from the beginning. We just didn't know it. Einstein called these hidden variables. He desperately wanted the universe to be like the gloves, defined, local, and sensible. For decades, this was just a philosophical debate. There was no way to test it. It was Einstein's word against Bohr's. But in 1964, an Irish physicist named John Bell did something brilliant. He found a mathematical way to tell the difference between gloves, hidden variables, and entangled coins, quantum mechanics. He proved that if the world was made of gloves, the statistics of measuring them would follow a certain pattern. If the world was quantum, the statistics would break that pattern. This was called Bell's theorem. In the 1970s and 80s, physicists finally built the machines to test it. Alain Aspect and his team in France fired entangled photons in opposite directions and measured them. They held their breath, waiting to see if the universe was local, like Einstein wanted, or non-local, like quantum theory predicted. The results came in. Einstein was wrong. The universe is not made of gloves. It is made of magic coins. The experiments proved that the particles truly do not have a definite state before they are measured. My electron here is not secretly up all along. It is genuinely undefined. And when I measure it, the universe performs some miracle. It coordinates the reality of the distant particle instantly, faster than light, faster than time. The two particles are not two separate objects sending messages to each other. They are one single object, one single wave function, stretched across millions of miles of space. Let that sink in for a moment. It suggests that distance is not a fundamental property of reality. Two things can be physically separated by the entire width of the observable universe. And yet, in the eyes of quantum mechanics, they are standing right next to each other. They are touching. The space between them is irrelevant. This is the terror of non-locality. It strips away our safety. It tells us that separation is a lie. If space can be bypassed so easily by entangled particles, then what is space? Is it just a projection? Is it a hallucination that our minds create to make sense of the data? Some physicists now believe that space-time is not the foundational layer of reality, but that it emerges from entanglement. They suggest that the universe is sewn together by these quantum threads, like a fabric stitched from invisible yarn. Without entanglement, space itself might dissolve. But the implications go even deeper into the history of everything. Think back to the Big Bang, 13.8 billion years ago. In that first fraction of a second, all the matter and energy in the universe was compressed into a singularity, a point smaller than a single atom. Everything was touching, everything was interacting, everything was entangled. As the universe exploded outward and expanded, those particles flew apart. They formed hydrogen, then stars, then galaxies, then planets, then you. But if they were entangled at the beginning, does that mean they are still entangled now? Are the atoms in your right hand subtly linked to the atoms in the heart of a star in the Virgo cluster? Is the carbon in your brain dancing in unseen synchronization with a cloud of methane drifting through the Orion Nebula? The theory suggests that there is a cosmic web of entanglement connecting everything to everything else. We are not isolated fragments moving through a void. We are part of a colossal, interconnected organism. The separation we feel, the skin that separates you from the air, the miles that separate you from your loved ones, the light years that separate Earth from the cosmos, is a superficial layer. Underneath, in the quantum dark, everything is holding hands. This sounds beautiful, but it is also overwhelming. It means there is no true isolation. You cannot cut yourself off from the universe. Every action, every measurement, every interaction forces a resolution in the web. We are pulling on strings that reach to the end of time. There is a caveat, of course. Scientists are quick to point out that we cannot use entanglement to send messages faster than light. You cannot use it to send a text message to Andromeda instantly. The results on the other side appear random until you compare notes, which requires normal, slow light-speed communication. This is nature's way of preventing time travel paradoxes. It is a no-signaling theorem that keeps the structure of causality intact. We cannot control the other end. We can only share a destiny with it. But the philosophical weight remains. If you are entangled with the universe, then you are not an observer looking at nature. You are a part of nature looking at itself. The boundaries of the self begin to blur. Where do you end and the rest of the world begin? If an electron in your brain is entangled with an electron in a falling leaf outside your window, are you partially the leaf? If the photons striking your eyes are entangled with the sun, are you partially the star? It challenges the very concept of individual. We spend our lives building walls, defining our egos, protecting our inner worlds. We say, this is me, and that is you. But quantum mechanics laughs at these walls. It says that at the deepest level, the universe is a holistic, indivisible whole. We are like waves on the same ocean, thinking we are separate because we can see the troughs between us, forgetting that we are made of the same water. This spooky action is not just happening in laboratories. It is happening in your body right now. Enzymes in your cells use quantum tunneling and potentially entanglement to speed up chemical reactions. Birds might use quantum entanglement in their eyes to see the Earth's magnetic field and navigate during migration. The phenomenon is not distant. It is woven into the machinery of life. We are quantum creatures living in a quantum world, pretending to be classical objects. As you lie in the dark, feeling the silence of the room, try to expand your awareness beyond the walls. Feel the city around you, the continent, the planet, the solar system. Imagine the invisible threads of connection radiating out from your body, passing through the roof, through the atmosphere, stretching out into the deep black void. Imagine them hooking into the dust of distant nebulas and the ice of frozen comets. You are not small. You are not isolated. You are vast. You are an integral knot in the tapestry of existence. The loneliness you feel when you look at the stars is a trick of the senses. In the quantum realm, you are touching those stars. You never stop touching them. The universe is holding you, and you are holding the universe in an embrace that has lasted for 13 billion years and will last until the end of time. This removes the fear of the void. The void is not empty. It is full of connection. It is full of relationship. We are not strangers here. We are home. The terror of non-locality dissolves into the peace of belonging. We are not distinct entities fighting for survival in a cold, indifferent machine. We are the machine. We are the cosmos, experiencing itself from a trillion different perspectives, all linked, all one. But if the fabric of the universe is held together by these delicate quantum threads, what happens if the fabric tears? What happens if the vacuum of space itself, the stage upon which all this dancing happens, is not as stable as we think? This brings us to a theory that does not just challenge our perception of reality, but threatens its very existence. A theory that suggests the ground beneath our feet, the empty space between the atoms, might be a trap door waiting to open. We are going to explore the concept of vacuum decay and the possibility that our entire universe is sitting on the edge of a bubble that could pop at any moment, erasing everything, atoms, forces, history, and hope in the blink of an eye, without us ever seeing it coming. There is a fundamental assumption that allows us to sleep at night. It is a belief so deep, so instinctual, that we never even think to question it. We believe that the ground beneath our feet is stable. I do not just mean the dirt and the rock. I mean the very laws of nature that hold the rock together. We assume that the rules of the game are fixed. We assume that an electron will always be an electron, that gravity will always pull, and that the fabric of space-time is a solid stage upon which the drama of our lives plays out. We look at the universe and we see a structure that has lasted for 13.8 billion years. We think, if it has lasted this long, it must be permanent. It must be safe. But the fourth theory on our journey into the quantum abyss suggests that this safety is a mirage. It suggests that the entire universe, everything we see and know, might be built on a foundation of ice that is slowly cracking. It suggests that at any moment, without any warning whatsoever, the laws of physics could simply snap, erasing reality as we know it in a fraction of a second. This is the theory of vacuum decay, often called the false vacuum catastrophe, and it is perhaps the most absolute end imaginable. To understand this terror, we have to talk about energy. In the universe, everything seeks the lowest possible energy state. This is the golden rule of nature. It is why water flows downhill, seeking the bottom of the valley. It is why a stretched rubber band wants to snap back. It is why a hot cup of coffee cools down. Nature wants to rest. It wants to reach the ground floor, the point of zero tension, the state of absolute stability. Physicists call this the ground state, or the vacuum state. When a system reaches this state, it is stable. It stops changing. It is safe. For a long time, we assumed that our universe was in this ground state. We looked at the empty space around us, the vacuum, and we thought, this is it. This is the bottom of the hill. We are at the lowest energy level possible. We believed that the fields that govern particle physics, the invisible grids that define how matter behaves, had settled into their final, comfortable positions billions of years ago. But in 2012, something happened that shook this confidence. Deep beneath the border of France and Switzerland, in the 27-kilometer ring of the Large Hadron Collider, scientists smashed protons together at nearly the speed of light. They were looking for a ghost, the Higgs boson, and they found it. This discovery was a triumph for science, proving the existence of the Higgs field, an invisible energy field that permeates the entire universe. You can think of the Higgs field as a cosmic ocean. Particles like electrons and quarks swim through this ocean, and their interaction with the fluid is what gives them mass. Without the Higgs field, you would have no mass. You would be a phantom of pure energy, flying at the speed of light, unable to form atoms, unable to become a solid being. The Higgs field is the anchor of our existence. But when physicists measured the mass of the Higgs boson, They found a number that was unsettling. It was roughly 125 giga-electron volts. To you and me, that number means nothing. But to a theoretical physicist, it was like finding a crack in the hull of a submarine. The math suggests that with a mass of 125, the Higgs field is not at the bottom of the valley. It is not in the true ground state. Instead, it appears that our universe is in a metastable state. Imagine a ball rolling down a hill. It wants to reach the very bottom, but halfway down, there is a little dip, a small valley nestled into the side of the mountain. The ball has rolled into this little dip and stopped. It looks stable. It is not moving. You can build a house next to it. You can build a civilization. You can build a universe. But it is not at the true bottom. The true bottom, the true vacuum, is 1,000 feet further down at the base of the mountain. We are living on a ledge. We are balancing on a fragile shelf of energy suspended above a terrifying drop. This is what we call a false vacuum. This would not be a problem if the laws of physics were classical. In a classical world, the ball would sit in that little dip forever, unless something pushed it up and over the ridge. But we do not live in a classical world. We live in a quantum world. And as we learned with the double-slit experiment, particles do not always follow the rules of solid objects. They can tunnel. A particle can disappear from one side of a barrier and reappear on the other without ever climbing over it. This leads to the nightmare scenario. If the Higgs field is metastable, there is a non-zero probability that at any moment, in any random point in the universe, a tiny patch of space could tunnel through the barrier. It could slip off the ledge and fall to the true bottom. If this happens, it will not just be a small adjustment. It will trigger a phase transition. Think of a bottle of supercooled water. You can put purified water in a freezer and cool it below 32 degrees Fahrenheit. And if you are very careful, it will stay liquid. It is metastable. It wants to be ice, but it needs a kick to start the process. But if you tap the bottle or drop a single grain of dust into it, that stability breaks. A crystal of ice forms, and then, in a beautiful, rapid cascade, that crystal grows. The freezing spreads outward, turning the entire liquid bottle into solid ice in seconds. Vacuum decay is the cosmic version of this freezing. If a bubble of true vacuum forms anywhere in the cosmos, it will have a lower energy level than the space around it. This difference in energy will drive the bubble to expand, and it will expand fast. It will push outward at the speed of light, consuming everything in its path. Inside this bubble, the laws of physics would be rewritten. The Higgs field would drop to a new value. The properties of particles would change instantly. The standard model of physics, the rule book that governs how atoms stick together, would be thrown into the fire. In the true vacuum, protons might decay. Electrons might become heavy. Electromagnetism might merge with the nuclear forces. Chemistry, as we know it, would become impossible. Atoms would simply fall apart. Matter would dissolve. The wall of this bubble would be a high-energy shell of pure destruction. As it expands, it would be like a cosmic eraser. If it hit a star, the star would not explode. It would simply cease to exist as a star. Its matter would be reorganized into whatever strange, unrecognizable physics exists inside the new vacuum. If it hit a galaxy, the galaxy would be unmade. It is the ultimate reset button, and here is the most terrifying part. Because the bubble expands at the speed of light, you would never see it coming. Information cannot travel faster than light. the light from the destruction, would arrive at the exact same moment as the destruction itself. You could be looking at the sky, admiring the moon, and then nothing. No warning, no siren, no time to hug your loved ones or say a prayer. One moment, you are a biological organism made of carbon and water, held together by the delicate balance of quantum forces. The next nanosecond, the rules that hold you together are gone. You would simply vanish. Your consciousness would be extinguished before your brain barely had time to register that the light had gone out. Some scientists have called this the sword of Damocles hanging over the universe. We are sitting at a banquet, eating and drinking and laughing, while a razor-sharp sword hangs above our heads by a single hair of horse's tail. We cannot see the hair. We do not know when it will snap. It could be 1 billion years from now. It could be 5 minutes from now. It could have happened 1 million years ago in a distant galaxy. And the wall of death is currently racing toward us through the dark, eating stars like a silent predator, destined to arrive next Tuesday. We simply do not know. The calculations of the Higgs mass are precise, but there is still some margin for error. We might be safe. We might be right on the edge of the stable zone. Or we might be deep in the danger zone, surviving only by sheer statistical luck. Stephen Hawking, one of the greatest minds of our time, warned about this possibility. He noted that the Higgs potential has the worrisome feature that it might become metastable at energies above 100 billion giga-electron volts. He said, "This could mean that the universe could undergo catastrophic vacuum decay, with a bubble of the true vacuum expanding at the speed of light. This could happen at any time, and we would not see it coming." Now, you might wonder, why on earth would you tell me this? How is this supposed to be a relaxing bedtime story? It sounds like the definition of anxiety. But I invite you to look at it differently. There is a strange, paradoxical peace to be found in the face of absolute inevitability. Most of our anxieties come from the illusion of control. We worry about our jobs because we think we can save them. We worry about our health because we think we can manage it. We worry about the future because we think we have to steer the ship. We carry the weight of the world on our shoulders because we believe it is up to us to keep it spinning. But vacuum decay tells us that the ultimate fate of the cosmos is completely, utterly out of our hands. It is a force of nature so grand, so swift, and so total that it renders all our little worries meaningless. It reminds us that existence is a gift, not a guarantee. The fact that you are here, right now, breathing and thinking, is a statistical miracle. You are balancing on a tightrope over an infinite abyss, and you have not fallen yet. There is a freedom in this realization. If the universe could end at any moment without warning, then the only moment that truly matters is this one. The past is a memory. The future is a probability. The now is the only reality we have. Vacuum decay forces us to be present. It strips away the pretense of legacy. It tells us that we are not building eternal monuments. We are building sandcastles at the edge of the tide. And that is okay. The beauty of a sandcastle is not that it lasts forever. Its beauty is in the joy of building it, the feel of the sand in your hands, the way it catches the sunlight for a brief afternoon before the ocean takes it back. The universe itself is a sandcastle. It is a temporary arrangement of stardust and energy painted on a canvas of fragile vacuum. The fact that it is temporary does not make it less beautiful, it makes it more precious. A flower that blooms for a single night is more captivating than a plastic flower that lasts for a century. We are the blooms on the night blooming Sirius of the cosmos. Furthermore, some physicists argue that vacuum decay might not be the end, but a new beginning. If the bubble hits us, yes, our version of physics dies. But inside the bubble, a new universe is born, a universe with new laws, new constants, perhaps new forms of life that we cannot even imagine. We might just be the precursor, the unstable scaffolding that needs to fall away to make room for a more stable, more permanent reality. We are the fuel for the next big bang. In this light, the destruction of the universe is not a tragedy. It is a transformation. It is the cosmos evolving, shifting its weight, settling into a more comfortable position. We are just along for the ride. So, tonight, as you lay your head on the pillow, feel the stability of the bed beneath you. Feel the gravity pulling you down. Acknowledge that it feels solid, but let a small part of your mind smile at the secret knowledge that it is all a delicate balancing act. The floor, the walls, the earth, the stars. They are all holding their breath. Let go of the need for permanence. Let go of the fear of the end. You cannot stop the bubble. You cannot outrun the light. All you can do is breathe. In, out, in, out. With every breath, you are defying the odds. With every beat of your heart, you are winning the cosmic lottery. You are here. You are conscious. You are the universe aware of itself, perched on the edge of a cliff, watching the sunset. The fragility of the universe makes your existence rare and exquisite. Do not waste it worrying about things you cannot change. Savor the stability while it lasts. Enjoy the show, because even if the screen goes black tomorrow, the movie we played today was magnificent. But if our physical reality is this fragile, if the very space we occupy is liable to collapse, it begs the question, is this physical reality even real in the way we think it is? What if the universe is not made of atoms and vacuum at all? What if the three-dimensional world we see, the depth of the room, the distance to the horizon, is actually a hologram? What if we are just information painted on the surface of a distant cosmic horizon, and everything we experience is a projection? This brings us to the fifth theory, a concept that completely reimagines the nature of space and suggests that we might be living in a lower dimensional universe than we think. We are about to explore the holographic principle and the possibility that you are not a solid body moving through space, but a smear of data encoded on the edge of forever. There is a simple, intuitive truth that you have known since you were a baby reaching out for your mother's face. It is the truth of depth. You know that the world has 3 dimensions. You can move up and down, left and right, forward and backward. When you hold an orange in your hand, you feel its volume. You know that the juice is inside, hidden behind the skin, occupying a space that is distinct from the surface. We live in a world of containers and contents. Your house is a box that contains your furniture. Your skull is a shell that contains your brain. Volume seems to be the fundamental measure of how much stuff can exist in a given place. If you want to store more clothes, you get a bigger suitcase. If you want to store more data, you build a bigger server room. We equate reality with volume. To be real is to take up space. But the fifth theory on our journey into the shadows of physics challenges this most basic assumption. It suggests that your sense of depth is a trick. It proposes that the 3-dimensional world you think you inhabit, the world of mountains and oceans and stars, is actually a projection. It suggests that the true reality is a flat, 2-dimensional surface located at the very edge of the universe, and everything you are, everything you feel, and everything you do is merely a holographic image generated from that distant data. This is called the holographic principle, and it forces us to ask a question that sounds like it belongs in science fiction. Are we real? Or are we just a simulation? To understand how serious scientists came to this mind-bending conclusion, we have to go back to the most extreme objects in the universe, black holes. For decades, black holes were a nightmare for physicists because they seemed to break the laws of nature. Specifically, they threatened to destroy information. In our universe, information is sacred. Quantum mechanics relies on the idea that if you know the state of a system now, you can reconstruct its past. Information is never lost. It is just scrambled. If you burn a book, the information in that book is not technically gone. It is turned into ash and smoke and heat. If you could capture every particle of ash and every photon of heat, you could theoretically reconstruct the book. The universe keeps a record of everything. But black holes seem to offer a way to erase that record. If you throw a book into a black hole, it crosses the event horizon and disappears. The black hole eventually evaporates through Hawking radiation. But for a long time, Stephen Hawking argued that this radiation was random. It did not carry the information of the book back out. When the black hole finally disappeared, the book was gone forever. The record was wiped clean. This was the information paradox, and it threatened to unravel all of physics. If information could be destroyed, then the past was not real. History could be deleted. A physicist named Leonard Susskind, along with Gerard 't Hooft, refused to accept this. They entered into an intellectual war with Stephen Hawking. They were desperate to save the sanctity of information, and to do it, they had to come up with a radical new way of looking at space. They looked at the entropy of a black hole. Entropy is a measure of disorder, but it is also a measure of information. How much data is hidden inside a system? Common sense tells us that the amount of information you can fit inside an object should depend on its volume. If you have a library, the number of books you can store depends on how much cubic space you have on the shelves. Double the volume of the room, and you can store double the books. But when physicists looked at the math of black holes, they found something bizarre. The amount of information a black hole could hold did not depend on its volume. It depended on its surface area. Let me repeat that because it is counterintuitive. The capacity of a black hole to store data is defined strictly by the size of its event horizon, the two-dimensional shell wrapping around it. It is as if the library's capacity did not depend on the room inside, but only on the square footage of the walls. Susskind realized that when an object falls into a black hole, its information is not lost in the deep, dark center. Instead, it gets plastered onto the surface. The three-dimensional object, the book, the spaceship, the astronaut, is translated into two-dimensional data and stored on the event horizon like a sticker on a suitcase. This was the solution to the paradox. The information is safe because it never truly leaves the observable universe. It is preserved on the shell, but it came with a staggering implication. If all the information about the three-dimensional interior is encoded on the two-dimensional surface, then which one is the real version? Is the book inside the hole real, or is the data on the surface real? The answer, according to the holographic principle, is that they are the same thing. They are just two different ways of describing the same reality. But the surface version is the more fundamental one. The three-dimensional object is a projection, a hologram, of the two-dimensional data. You have seen holograms on credit cards or in science museums. They are flat, two-dimensional pieces of plastic, but when light hits them just right, a three-dimensional image pops out. You can look around the image, see its sides, perceive its depth. It looks real. It looks like it takes up volume. But if you try to grab it, your hand passes through light. The reality is the flat plastic. The image is a trick of light. Susskind and others took this logic and applied it to the biggest container of all, the universe itself. If the physics of black holes allows 3 dimensions to be encoded in 2, why should the rest of the cosmos be different? We live in a universe that has a horizon, the cosmic horizon, the limit of how far we can see. The holographic principle suggests that the entire universe is like the inside of a black hole. Imagine a vast sphere surrounding the entire observable cosmos. The surface of this sphere is paved with tiny, plank-sized pixels of data. These pixels are the smallest possible units of space, billions of times smaller than an atom. Everything that happens inside the sphere, the birth of stars, the orbit of planets, the thoughts in your brain, the beating of your heart, is actually a computation taking place on that distant shell. You are not sitting in a room right now. In the deepest sense, you are data spread out across the edge of the universe. The laws of physics are the software that projects that data inward, creating the convincing illusion that you are a solid body occupying a point in 3-dimensional space. The here, where you think you are, is just a focal point of the projection. The real you is everywhere, smeared across the cosmic horizon. This idea creates a profound sense of vertigo. It makes the world feel insubstantial, like a dream. If you touch the wall next to you, you feel resistance, you feel hardness. But that hardness is just a calculated result of the data interaction. It is like a video game character bumping into a wall. The code says stop, so the character stops. The wall in the game is not solid, it is just a rule. In the holographic universe, the atoms in your finger and the atoms in the wall are just interacting bits of information on the cosmic screen. For years, this was just a mathematical curiosity, a way to solve black hole equations. But then, scientists started looking for evidence. A device called GE0600, a gravitational wave detector in Germany, began picking up a strange noise. It was a persistent, unexplained static in the data. The lead scientist, Craig Hogan from Fermilab, proposed a stunning explanation. He suggested that the detector might have hit the fundamental limit of space-time resolution. Think of a digital photo. If you zoom out, it looks smooth and continuous. But if you zoom in far enough, you see the pixels. You see the jagged edges where the information ends. Hogan suggested that the noise in GE0600 might be the pixels of the universe. The detector might be sensitive enough to feel the graininess of the hologram. It might be hearing the digital hum of the cosmic code. While this result is still debated and far from conclusive, the possibility remains. We might be living in a pixelated reality. We might be able to measure the resolution of our own existence. This theory can be terrifying because it strips us of our physical sovereignty. It implies that we are not autonomous beings of matter, but puppets of light and information. It makes us feel like characters in a movie, unaware that we are just images on a screen. Plato, the ancient Greek philosopher, imagined prisoners chained in a cave, watching shadows dancing on the wall. They believed the shadows were real because they had never seen the objects casting them. The holographic principle tells us that we are all in Plato's cave. The world we see is the shadow. The reality is the data on the wall. But there is another way to look at this, a way that transforms the terror into a strange kind of beauty. If the holographic principle is true, it means that information is the most fundamental substance of the universe. We are not made of clay. We are made of code. We are made of meaning. It also implies a profound level of connectivity. In a three-dimensional world, things are separate. You are here. I am there. There is distance between us. But on the holographic surface, the data that makes up you and the data that makes up me might be overlapping. The information describing the entire universe is entangled on that 2D shell. In the source code, there is no distance. Everything is written on the same page. This resonates with many ancient spiritual traditions that claim the world of forms is an illusion, Maya, and that the true reality is a unified field of consciousness or being. Physics is arriving at a similar conclusion through the path of mathematics. The solidity of the world is a convenient user interface. Underneath, it is all one interconnected flow of information. Furthermore, being a hologram does not make your experiences less real. The pain you feel, the love you share, the taste of morning coffee, these are the qualia of your consciousness. Even if they are generated by a projection, the experience of them is undeniable. A story is not fake just because it is written in ink on paper. The characters in a great novel feel real emotions, even if they are made of words. We are the stories the universe is telling itself. We are the poetry written on the horizon. There is also a comforting permanence in the idea of information conservation. If the holographic principle was born to save information from black holes, it means that in a holographic universe, nothing is ever truly lost. Every moment you have lived, every thought you have had, is encoded on the boundary of the cosmos. You are a permanent record. The universe does not delete its data. It might scramble it, it might disperse it, but the essential description of who you are is etched into the very fabric of reality. You are written into the sky. So, look around your room again. It looks deep, it looks spacious. But close your eyes and imagine the sphere of the universe. Imagine that you are actually a vast, complex pattern of data shimmering on that distant shell. You are being projected inward, focusing into this moment, into this body. To experience this specific point of view, you are not small. You are as big as the universe, folded up into a tiny package. The depth of the world is an illusion, but the depth of you is infinite. You are an expression of the cosmic code. And just like a hologram, if you cut a piece of the film, the whole image is still contained in the fragment. In every part of you, the whole universe is hidden. But if space is a projection and depth is a trick, we must turn our attention to the other great pillar of our reality, time. We feel time flowing. We feel the past slipping away and the future rushing toward us. We feel that we are moving through time like a ship moving through water. But the next theory on our list suggests that this, too, is a lie. It suggests that time does not flow at all. It suggests that the past, the present, and the future all exist simultaneously, frozen in a giant block of crystal. We are about to explore the theory of the block universe, or eternalism, and the terrifying possibility that your future has already happened and you are just watching the replay. We live our lives trapped in the tyranny of the ticking clock. We feel time as a relentless current, a river that flows in one direction, carrying us from the safety of the past toward the uncertainty of the future. We organize our entire existence around this flow. We grieve for what is gone, believing it has vanished into the void behind us. We anxiously plan for what is to come, believing it has not yet been written. We feel that the now is the only thing that is real, a razor-thin edge of light moving through the darkness. We believe that we are free agents, standing at the helm of our lives, steering our ships into an open ocean of possibility. But the sixth theory on our journey into the scientific shadows suggests that this entire model of reality is a lie. It suggests that the river does not flow. It suggests that the past is not gone, and the future is not unwritten. It tells us that time is not a process, it is a place. We are about to enter the frozen crystal of the block universe, a theory that implies your birth, your death, and every moment in between are all happening simultaneously, forever. To understand why physicists believe something so contrary to our daily experience, we have to look at the work of Albert Einstein. Before Einstein, we thought of space and time as separate things. Space was a stage, and time was a clock on the wall. The clock ticked at the same rate for everyone, everywhere. A second on Earth was a second on Mars, was a second in the Andromeda Galaxy. Now was a universal moment shared by the entire cosmos. But in 1905, and later in 1915, with general relativity, Einstein shattered this clock. He realized that time is not a constant universal beat. It is flexible. It stretches and squeezes depending on how fast you're moving and how much gravity you're feeling. If you move fast, time slows down for you relative to someone standing still. If you stand near a black hole, time crawls. This means that now is not a universal concept. It is a local illusion. Two observers moving at different speeds will disagree on what is happening right now. And here is the terrifying part. They will both be right. Let me give you a specific example known as the Andromeda paradox. Imagine you are sitting on a park bench on Earth. 2.5 million light years away is the Andromeda Galaxy. Now, imagine an alien in that galaxy is driving a hover car. If the alien is hovering still relative to you, his now might align with your now. Maybe he is eating his lunch at the exact same moment you're reading this sentence. But if the alien simply accelerates his car toward Earth at a walking pace, just a few miles per hour, his definition of now on Earth shifts wildly. Because of the vast distance and the angle of his movement through space-time, his slice of now tilts into your future. By simply driving his car, his now might jump to a Tuesday next week on Earth. In his slice of the universe, you are already doing whatever you will be doing next Tuesday. The future you, who thinks they have not made their choices yet, already exists in the alien's present. Conversely, if the alien drives away from Earth, his now slices into your past. In his reality, you might be a child again, or perhaps you haven't even been born. This is not just a trick of light or a delay in signaling. According to special relativity, those moments are his present reality. If the laws of physics are consistent, this implies that the past, the present, and the future must all be equally real. You cannot have a universe where the alien's now includes your future unless your future is already there, waiting to be included. This leads to the concept of the block universe, or eternalism. Imagine a loaf of bread. You can slice the loaf straight down, creating slices of now. But you can also slice it at an angle. The loaf itself, the whole block of bread, exists all at once. The slices are just different perspectives. In this view, the universe is a 4-dimensional block, 3 dimensions of space, and 1 dimension of time. The entire history of the cosmos, from the Big Bang to the heat death, is a single, static, unchanging structure. It does not happen. It simply is, From the outside, looking at this block, there is no flow. There is no motion. The dinosaurs are still hunting in the slice labeled Jurassic. You are still being born in the slice labeled with your birth year. You are reading this right now in this slice, and you are dying in a slice further down the block. All of these events exist simultaneously in the hyper-rectangle of space-time. This is terrifying because it kills free will. If the future is already there in the block, sitting just a few inches away in the fourth dimension, then you are not creating your life. You are discovering it. The choices you think you are agonizing over, whether to marry, whether to quit your job, what to have for dinner, have already been made. The outcome is fixed in the crystal of time. You feel like you are choosing, but that feeling is just the biochemical reaction of your brain processing the script that was written 13 billion years ago. We are like characters in a movie. When you watch a movie, the characters do not know the ending. They struggle, they cry, they fight. They feel like they are making decisions. But the film reel is already in the can. The end of the movie exists physically on the reel at the same moment the beginning does. We are just the light of consciousness shining through one frame at a time, creating the illusion of motion. Einstein himself found a strange comfort in this. When his best friend Michel Besso died, Einstein wrote a letter to Besso's family. He said, "Now he has departed from this strange world a little ahead of me. That means nothing. People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion." Einstein was saying that his friend was not gone. He was just at a different coordinate in the block. He was still alive, still laughing, still breathing, back in the 1920s, back in the 1940s. Those moments were not erased. They were just elsewhere. This is the beautiful, heartbreaking flip side of the terror. If the block universe is real, then nothing is ever lost. We are terrified of death because we view it as a cliff we fall off. We think that after we die, we are gone. But in a block universe, death is just a boundary, like the border of a country. Canada does not cease to exist just because you crossed into the United States. Your childhood does not cease to exist just because you became an adult. The time you spent with your grandparents, the time you held your first love's hand, the quiet Sunday mornings of your youth, they are all still there. They are permanent fixtures in the architecture of reality. They are as solid as a mountain. You cannot visit them again because your consciousness is moving forward through the block, but they are safe. They are preserved in amber. In this sense, we are all immortal. Our lives are statues carved into time, unchangeable and eternal. But the feeling of being a puppet is hard to shake. It generates a profound claustrophobia. We want to believe we can change course. We want to believe that the future is a cloud of mist that we can shape with our hands. The block universe tells us it is a block of concrete. If you are destined to drop a cup 5 minutes from now, that broken cup is already lying on the floor in the future slice of the universe, even while you hold it safely in your hand in the present slice. The cause and the effect are just two patterns in the carpet. Some physicists have tried to find a way out of this trap. They look to quantum mechanics, to the uncertainty we discussed in earlier chapters, hoping that maybe the future is not fixed. Maybe the block is growing. Maybe the past is solid, but the future is fuzzy, crystallizing only as we reach it. This is called the growing block theory. It gives us back our free will. It gives us back the open ocean. But relativity is a harsh master. The math points strongly to the static block. The fact that space and time are fused means you cannot easily have one without the other. If you want a consistent universe where physics works for everyone, regardless of their speed, you seem to be stuck with the block. There is a way to navigate this that combines the terror with peace. Think of a song. When you listen to a symphony, the notes at the end of the piece exist on the sheet music at the same time as the notes at the beginning. The symphony is a fixed structure. Does that ruin the beauty of the music? Does the fact that the final chord is already written make the melody less moving? No, we do not listen to music to get to the end. We listen to experience the flow. Perhaps our lives are like that song. The melody is written, the notes are fixed. But we are here to play the music. We are here to feel the rise and fall, the tension and the resolution. The fact that the script is finished does not mean we do not have to act it out with passion. We are the instrument through which the universe experiences its own history. So, as you wait for sleep to come, think about the moments of your day, the coffee you drank this morning, the sunset you watched. Do not think of them as gone. Think of them as existing still, just a little way down the road behind you. And think of tomorrow not as a blank void, but as a landscape waiting for you to arrive. The hills and valleys of your future are already there, shrouded in mist. You will walk them when you get there. There is a deep, quiet safety in the block universe. It means you cannot make a mistake. You cannot ruin your life. You can only live the life that is yours. The path is laid. The destination is certain. Your only job is to walk, to breathe, to watch. You are safe inside the crystal of eternity. But if our consciousness is just a light moving through a pre-written script, we have to ask, what is the nature of this consciousness? Where does it come from? And can we trust it? This brings us to a theory that creates a crisis of self so severe it makes the block universe look tame. It suggests that your memories, your history, and even the universe you see around you might be a random hallucination that formed out of chaos just 1 second ago. We are about to confront the Boltzman brain hypothesis, the idea that you might be a lonely mind floating in the void, dreaming of a life that never happened. There is a sanctuary we all retreat to when the world becomes too confusing or too painful. That sanctuary is the past. We trust our memories. We believe that no matter what happens tomorrow, what happened yesterday is safe. It is locked away in the vault of history. You know who you are because you remember growing up. You remember the smell of your elementary school classroom. You remember the taste of your first birthday cake. You remember the sound of your mother's voice. These fragments are the bricks that build the house of your identity. You believe that these memories are recordings of real events that took place in a physical universe, involving real people who existed independently of you. You assume that you are a biological organism that evolved over billions of years, the product of a long, coherent chain of cause and effect, living on a planet that has orbited a star for eons. But the seventh theory on our descent into the quantum madness asks us to destroy this final sanctuary. It suggests that your memories are not records. They are fiction. It suggests that you did not evolve. You were not born. It suggests that you and the entire universe you perceive around you might have popped into existence just 1 second ago, fully formed, out of pure chaos, and that in another second you will dissolve back into the void. This is the Boltzman brain hypothesis, and it is the ultimate expression of cosmic loneliness. To understand how science could possibly arrive at such a nightmare, we must speak of Ludwig Boltzmann, an Austrian physicist in the late 19th century, who looked deep into the nature of disorder. Boltzman was obsessed with a concept called entropy. Entropy, in simple terms, is a measure of messiness. It is a measure of how many ways you can rearrange the components of a system without changing its overall appearance. A neat stack of papers has low entropy. There is only one way to stack them perfectly. A pile of papers scattered all over the floor has high entropy. There are millions of ways they can be scattered and still just look like a mess. The second law of thermodynamics states that in a closed system, entropy always increases. Things tend to go from order to disorder. Coffee cools down, buildings crumble, stars burn out. The universe is slowly marching from a state of low entropy, the highly organized Big Bang, to a state of maximum entropy, the heat death, where everything is a uniform, lukewarm soup of particles with no structure, no life, and no future. This is the arrow of time. But Boltzman realized something profound about entropy. It is statistical. It is not a law that cannot be broken. It is just a law that is incredibly unlikely to be broken. If you have a box of gas with all the molecules gathered in one corner, low entropy, they will naturally spread out to fill the box, high entropy. But if you wait long enough, and I mean an unimaginably long time, eventually, just by random chance, the molecules might bounce against each other in just the right way to clump back into the corner for a split second. It is not impossible. It is just rare. These rare reversals of entropy are called thermal fluctuations. Now, here is where the terror begins. Boltzman imagined a universe that is eternal. If the universe lasts forever, then it will spend the vast majority of its time in a state of heat death, a high entropy chaos of thermal equilibrium. In this eternal chaos, particles are constantly bumping into each other randomly. Most of the time they accomplish nothing. But given infinite time, eventually, they will randomly bump into each other to form a structure. Small structures are more likely than big ones. It is more likely for the particles to randomly form a single hydrogen atom than to form a star. It is more likely for them to form a simple bacteria than a dinosaur. And this is the crux of the argument. It is vastly more likely for the particles to randomly arrange themselves into a single functioning human brain than it is for them to arrange themselves into an entire universe containing billions of galaxies, stars, evolution, and history. Think about it. The universe we see is huge and complex. It requires a staggering amount of order. The odds of a Big Bang happening by chance, followed by billions of years of evolution leading to you, are astronomically low. But the odds of a small patch of chaos randomly fluctuating into just one brain, complete with false memories of a Big Bang and evolution, are much, much higher. This leads to the terrifying conclusion. If our universe is eternal, or if it is part of a multiverse that lasts forever, then the vast majority of conscious observers should not be evolved biological beings like we think we are. They should be Boltzmann brains, disembodied minds that spontaneously materialized out of the vacuum for a few moments, hallucinating a life before vanishing again. Statistically, you should be one of them. The math says that for every one real observer who actually evolved on a planet, there should be trillions upon trillions of Boltzmann brains floating in the void. Therefore, it is overwhelmingly probable that you are one of them. This means that everything you think is real is a lie. Look at your hands. You think they are made of flesh and blood, evolved from primates. But in this theory, they are just a temporary arrangement of atoms that formed by chance a moment ago. The room around you, the walls, the computer, the window, is not really there. It is a sensory hallucination being fed to your brain by the random configuration of neurons. You think you have a past. You remember breakfast. You remember your childhood. You remember your first kiss. But those memories were written into your brain at the exact moment of its creation just a second ago. They are false data. Backstory for a character that just walked onto the stage. You might say, but I feel the continuity of time. I feel seconds passing. But the Boltzman brain only lasts for a brief moment. Your entire experience of reading this script might be the entire lifespan of your existence. In the next moment, the fluctuation will destabilize. The particles will disperse. Your consciousness will wink out, returning to the equilibrium of the void. You are a bubble of thought popping in an ocean of nothingness. This form of skepticism is called solipsism, but it is solipsism weaponized by physics. It is the loneliest thought a human being can have. It implies that you're the only thing that exists. Your family, your friends, your pets, the artists you love, the scientists you admire, they are all just phantoms in your mind. The love you feel for them is real to you, but the people themselves are not there. You are hallucinating a crowded room while sitting alone in the deepest, darkest desert of eternity. Scientists hate this theory. They call it the Boltzman brain paradox. They do not want it to be true. If it is true, then science itself is impossible. We rely on evidence, fossils, starlight records, to understand the universe. But if all that evidence is just a false memory in a fluctuating brain, then we cannot learn anything. We cannot trust our observations. We cannot trust the laws of physics. We cannot even trust the logic we are using to discuss Boltzmann brains. It is a cognitive dead end. It is madness. So, cosmologists use this paradox as a test. They say, any theory of the universe that predicts there are more Boltzmann brains than real observers must be wrong. They use it to rule out certain models of the multiverse or eternal inflation. They are desperately trying to find a model of the cosmos where the Big Bang is not a random fluctuation, but a necessary event, or where the universe decays fast enough that Boltzmann brains do not have time to form. They are fighting to prove that we are real, but the fear lingers. Because we cannot prove we are not Boltzmann brains, there is no test you can perform. If you pinch yourself, the feeling of the pinch is just part of the hallucination. If you call a friend and ask, "Are you real?" their voice answering, "Yes," is just auditory data generated by your spontaneous neural pathways. You are trapped in the box of your own mind, with no windows to the outside. Let us try to visualize what this implies about the nature of consciousness. Imagine the void of deep space, far into the future, long after the stars have gone dark. It is cold, it is empty, it is dead. But in the darkness, particles are dancing. They swirl and collide for eons, forming nothing but dust. But then, by sheer chance, a cluster of atoms comes together. A spark fires. A thought appears. I wonder what is for dinner? And then, instantly, the atoms drift apart. The thought vanishes. Later, another brain forms. It thinks, I love her so much. Then it dissolves. Another forms. Why is it so dark? Dissolve. The void is filled with these flickering sparks of isolated experience. Most of them are incoherent. They are flashes of pain, or color, or nonsense. But occasionally, a brain forms that is perfect. A brain that thinks it is you. A brain that thinks it is sitting in a chair, reading a script about quantum theories, feeling a vague sense of unease. That brain has a complete, consistent internal world. It knows the history of Rome. It knows the plot of Star Wars. It knows the taste of peppermint. It is a masterpiece of random assembly. And it is completely alone. The terror of the Boltzmann brain is the terror of meaninglessness. If we are just random fluctuations, then our lives have no narrative. There is no journey. There is no growth. We are just static on the television screen of the universe, momentarily forming a shape that looks like a face before dissolving back into snow. However, there is a strange, paradoxical beauty here too, if you have the courage to look for it. Even if you are a Boltzman brain, the experience you are having is undeniable. The feeling of I am is the one thing that cannot be an illusion. Descartes said, "I think, therefore I am." He did not say, "I think, therefore I have a body," or "I think, therefore the past is real." He just established the reality of the present moment of consciousness. If you are a Boltzman brain, then this moment, right now, is a miracle of probability. Out of the infinite chaos, the universe has conspired to create a moment of coherence. It has created a mind capable of wondering about its own existence. You are a jewel of order in a sea of disorder. Even if you only last for a second, that second is precious. It is a victory against the void. And think about the memories you hold, real or false. They are beautiful. The memory of a sunset, even if you never saw the sun, is a beautiful pattern of information. The feeling of love, even if the lover never existed, is a beautiful state of being. The universe has generated art out of noise. You are that art. Furthermore, most physicists argue that we are probably not Boltzmann brains. The argument goes like this. Boltzmann brains should be witnessing a chaotic, nonsensical world. If your brain formed randomly, it would be much simpler for it to hallucinate a blank room than a room filled with complex books and consistent physics. The fact that you see a universe that follows strict, logical laws, and that those laws have remained consistent for as long as you can remember, suggests that you are indeed a normal observer living in a real, low-entropy universe. The consistency of reality is our shield against the madness. We are likely biological beings, born of stardust, evolved through the slow, grinding magic of natural selection. We are the legitimate children of the Big Bang, not the bastard children of thermal noise. We belong here. The past actually happened. The people you love are real. But the Boltzmann brain hypothesis serves as a humble reminder. It reminds us that consciousness is a mystery. We do not know how matter generates mind. We do not know why we are here. We are fragile things, webs of electricity and chemistry, holding on to our sense of self against the crushing weight of entropy. It also changes how we relate to the present moment. If the past is memory and the future is imagination, then the now is the only place where we truly touch reality. The Boltzmann brain only has now, and in a way, so do we. We are always surfing the crest of the present, moving from one state of being to the next. So, take a deep breath. Feel the air filling your lungs. That sensation is vivid. It is textured. Whether it comes from a real atmosphere or a random fluctuation, it is yours. You are feeling it. You are the witness. And as you exhale, send a thought out to those potential trillions of lonely minds flickering in the deep future, the lost sparks of the cosmos. Wish them well. They are your brothers and sisters in consciousness. They are the universe trying to wake up over and over again in the dark. But we are the lucky ones. We are the ones who get to wake up together. We get to share the hallucination. We get to agree on the color of the sky and the meaning of words. We are not alone. We are entangled in a shared history, anchored in a shared reality. And that shared reality, no matter how fragile, is something to be grateful for. But this brings us to the final question. If we are real, and the universe is real, where is it all going? We have talked about the end of the individual, the end of the vacuum, and the end of truth. But what is the ultimate fate of the stage itself? What happens when the arrow of time hits its target. We are approaching the end of our journey, the final theory that describes the ultimate darkness, and perhaps the ultimate hope. We are going to look into the face of the heat death, and the possibility that the end is not an end, but a necessary breath before the next beginning. We began this journey by looking at the smallest things imaginable. The atoms in your hand, the electrons dancing in the dark. We have traveled through the splitting branches of the multiverse, walked across the bridge of entanglement, and stood on the precipice of vacuum decay. We have questioned the solidity of space and the flow of time. But every story must have an ending, and the story of the universe is no exception. We humans have a complicated relationship with endings. We fear the dark. We fear the silence. We fear the moment when the music stops and the lights go out. But the final theories on our list suggest that the darkness is not something to be feared. It is the natural state of things. It is the great ocean from which we emerged and to which we must eventually return. We are going to look at the three possible fates that await our cosmos: the Big Rip, the heat death, and the Great Cycle. These are the 8th, 9th, and 10th theories on our list, and they represent the ultimate horizon of scientific thought. They are the terrifying, beautiful answers to the question, how does it all end? To understand the 8th theory, we must return to the mysterious force we touched upon earlier: dark energy. We know that the universe is expanding. We know that this expansion is accelerating, pushing galaxies apart faster and faster every day. For a long time, physicists assumed that this dark energy was a constant force, a steady wind blowing the galaxies away from each other. If it is constant, the universe will simply get colder and lonelier forever. But some theoretical models suggest that dark energy might not be constant. It might be getting stronger. This hypothetical form of hyper-aggressive dark energy is called phantom energy. If phantom energy exists, it leads to a scenario known as the Big Rip. It is perhaps the most violent end imaginable. In this scenario, the expansion of the universe becomes so powerful that it overwhelms gravity. First, it tears the galaxy clusters apart. Then, it tears the galaxies themselves apart. The Milky Way would be shredded, its stars flung out into the void. But the phantom energy does not stop there. It continues to grow stronger until it overcomes the gravity of solar systems. Planets would be ripped away from their stars. Earth would drift alone into the dark. Then, in the final moments, the expansion becomes stronger than the electromagnetic and nuclear forces that hold matter together. Stars would be torn apart. Planets would explode. And finally, the atoms themselves, the very building blocks of you and me, would be ripped asunder. The space between the electrons and the nucleus would expand faster than the speed of light. Every single particle in the universe would be isolated, unable to interact with any other particle. The universe would end in a sudden, total shredding of all structure. It is a terrifying thought that the very fabric of space could become a monster that devours its own children. But most physicists believe that the Big Rip is unlikely. They point to a different ending, one that is slower, quieter, and perhaps more melancholic. This is the 9th theory, and it is the standard model of our cosmic demise. It is called the heat death, or the Big Freeze. The heat death is the ultimate victory of entropy. It is based on the simple fact that stars run out of fuel. Right now we live in the stelliferous era, the age of stars. The night sky is bright with the glow of nuclear fusion. But this is a temporary phase. It is a brief party in a very long night. In about 5 billion years, our sun will die. In about 100 trillion years, the last red dwarf star in the universe will exhaust its hydrogen and fade into darkness. When the last star dies, the universe will enter the degenerate era. The only light will come from the faint glow of white dwarfs, neutron stars, and black holes. But even these will not last. The white dwarfs will cool down until they become black dwarfs, cold, dark balls of dense matter floating in the void. They will be invisible, wandering through a graveyard of galaxies. This era will last for a time so long that human language fails to describe it. But eventually, even the matter inside the black dwarfs might decay. If protons are unstable, as some grand unified theories suggest, then all solid matter will eventually dissolve into radiation. The only things left will be black holes and wandering particles of light. Then comes the black hole era. For eons upon eons, supermassive black holes will rule the dark. They will sweep up the remaining dust, growing larger and lonelier. But as we discussed with Hawking radiation, black holes are not immortal. They slowly evaporate. Over timescales of Google years, a 1 followed by 100 zeros, the black holes will radiate away their mass and vanish in final, silent puffs of gamma rays. And then comes the dark era. The universe will be a vast, expanding sea of photons and neutrinos. The temperature will be absolute zero. Nothing will happen. Nothing can happen. The universe will have reached maximum entropy. Time will cease to have meaning, because there will be no events to mark its passage. There will be no before and no after. Only an eternal, unchanging now of perfect stillness. This is the heat death. It sounds bleak. It sounds like a tragedy. We want the story to go on forever. We want to believe that life finds a way. But the laws of thermodynamics are strict. The energy gradient that allows life to exist must eventually smooth out. The fire must eventually burn down to ash. However, there is a way to look at the heat death that is not terrifying, but deeply peaceful. Think of the universe as a living thing that has worked hard. It exploded into being with the violence of the Big Bang. It worked tirelessly to forge elements, build galaxies, create stars, and evolve minds. It has been screaming with energy and activity for billions of years. The heat death is simply the universe finally getting to rest. It is the long, well-deserved sleep after a busy day. It is the settling of the dust. It is the return to the equilibrium of the void. There is a dignity in the silence, a perfection in the stillness. But is this truly the end? Is the heat death the final period at the end of the sentence? Or is it just a pause between breaths? This brings us to the 10th and final theory on our list, a theory that offers a glimmer of hope in the face of the infinite dark. It comes from one of the most brilliant mathematical minds of the last century, Sir Roger Penrose. It is called conformal cyclic cosmology. Penrose looked at the heat death and noticed something strange about the geometry of the universe. In the far, far future, when all matter has decayed into radiation and all black holes have evaporated, the universe will contain only photons. Photons are particles of light. They have no mass. And because they have no mass, they do not experience time. To a photon, the moment it is created and the moment it is absorbed are the same moment. Distance means nothing to a photon. Scale means nothing to a photon. In a universe filled only with massless radiation, the concepts of big and small lose their meaning. If you have no rulers, no massive particles to define a scale, then a universe that is infinitely large looks geometrically identical to a universe that is infinitely small. Penrose suggests that this state of infinite expansion, this cold, empty, massless future, is mathematically indistinguishable from the state of the Big Bang, the hot, dense singularity from which we emerged. The end of one universe is the beginning of the next. He proposes that our universe is just one aeon in an infinite chain of aeons. The heat-death is not a death, it is a transition. When the universe forgets how big it is, it snaps back into a singularity, triggering a new Big Bang. A new universe is born from the ashes of the old. New stars, new galaxies, new life, new observers. This is the ultimate resurrection. It suggests that we are not living in a one-shot reality that travels from birth to death. We are living in a breathing cosmos. The universe exhales, expanding and cooling over trillions of years. Then, in the mystery of conformal geometry, it inhales, resetting the clock and starting the dance all over again. If this theory is true, then you have happened before, and you will happen again. The specific arrangement of atoms that makes up your body, your brain, your memories, given infinite time and infinite cycles, will eventually repeat. The love you feel is not a fleeting spark in the dark. It is a recurring theme in the symphony of eternity. The consciousness that looks out of your eyes is an ancient, perhaps eternal witness to the cycle of being. We have traversed the landscape of the quantum and the cosmic. We have looked at the terror of being watched, the vertigo of the multiverse, the ghostliness of entanglement, the fragility of the vacuum, the illusion of depth, the frozen block of time, the loneliness of the Boltzman brain, and the final silence of the end. And what have we found? We have found that the universe is far stranger than we ever imagined. We have found that the solid world of our senses is a thin veneer over a reality of shimmering probability and deep connection. We have found that we are not separate from the cosmos. We are the cosmos. We are the way the universe knows itself. We are the way the universe feels fear and wonder and awe. The terror of these theories comes from the loss of the familiar. We are afraid to lose the solid ground. We are afraid to lose our sense of self. But in exchange for that safety, science offers us something greater. It offers us the infinite. It tells us that we are part of a story that is vast beyond comprehension, a story written in light and gravity, a story that never truly ends. So, tonight, as you drift off to sleep, do not be afraid of the dark. The dark is just the space between the stars. It is the canvas upon which the hologram is painted. It is the womb of the next universe. You are safe. You are held by the laws of physics. You are anchored by the Higgs field. You are woven into the web of entanglement. You are a necessary part of the block of time. You are here, now, in this precious slice of reality. Let the mysteries we have discussed settle in your mind like falling snow. Let them cover the sharp edges of your daily worries. Let the vastness of the big rip and the silence of the heat death make your own problems feel small and manageable. You are a child of the universe, and the universe is taking care of you. It has carried you through 13 billion years of chaos to bring you to this quiet room, to this soft bed, to this moment of rest. Close your eyes. Feel the gravity of the planet pulling you down, holding you close. Listen to the silence. It is not empty. It is full of potential. It is full of the future. It is full of you. And if, in your dreams tonight, you find yourself floating in the quantum void, or walking through the halls of a multiverse, or watching the birth of a new aeon, do not be afraid. Just watch, just wonder, because you are the observer, and without you, the universe would have no one to admire its beauty. Good night, fellow traveler. The journey continues in the morning. But for now, let the wave function collapse into sleep. Let the particles come to rest. The universe will be here when you wake up.